I want to first recap our three different forms of a quadratic. Okay. We have standard form. This one is probably the most useless as far as being able to tell anything from the graph. This is probably the first way you learned how to graph a quadratic, though. You probably learned you can find the axis of symmetry at x equals negative b over 2a. Then you plug that value in to find the y, you get the vertex. Right? I mean, that's one of the first ways that we learn about graphing quadratics, but you have to use all those formulas in order to make it useful at all. So, again, I would say the best thing about it is that axis of symmetry formula, which is x equals negative b over 2a. And that gives you the vertical line that cuts the graph into two equal pieces, right, where it's symmetric on either side. Also, another good thing from standard form is you can find the y-intercept. The y-intercept is always the c value if you are in standard form. So whatever the c is, that's the y-intercept. So with vertex form, it looks like f of x equals a times x minus h squared plus k. Big shocker, vertex form is good at finding the vertex. The vertex happens at hk, which tells me how much did I move right or left, up or down. And notice that the h has the opposite sign, right, because there's a built-in negative there, so it goes the opposite from whatever the sign of the number is originally. And then the last one is factored form. F of x equals a times x minus p times x minus q. So again, opposite signed again. P and Q are your x-intercepts. And this is where we learn we've got the formula. We can find the a value by taking the y-intercept and dividing it by p times q. That's the new formula that I found out halfway through the lesson yesterday. On paper, it was challenge 8 on the slideshow that we did yesterday. So if I was asked to write an equation for this graph, I want to know what key characteristics do I know? I know both x-intercepts. That automatically makes me think I want to put this in factored form because I know where the x-intercepts are. So in factored form, I would have f of x equals, I still don't know what a is, right? There could be some stretch or compression. I don't know what it is yet. But if my x-intercepts, this one is at positive 2, that means I have to write x minus 2, because again, it's opposite signed. There's a negative in the formula. This x-intercept is at negative 6, which means I need to put x plus 6 there. Questions so far about what we've done? So how could I find the a? Well, to use that formula, I must know both x-intercepts, I do, and the y-intercept. I don't know the y-intercept yet, but I can find it. We know all quadratic functions are symmetric. And because these x-intercepts both have a y of 0, the axis of symmetry must be halfway between them. So however you want to figure that out, you could start on both sides and count over. I'm here, here, there, agree. That's the axis of symmetry. It has to go through this point. So I'm going to use that fact. I know the axis of symmetry is at x equals -2. Which means the x-intercepts are equally spaced on either side of it. Let me use a different color besides black, because that kind of just looks like dots. Well, I know one other point. Well, guess what the axis of symmetry does? It has to be the same point equally spaced on the other side, which means there is definitely a point at 0, 3. So now I do know the y-intercept. So I can find the a value by plugging in y-intercept 3 over x-intercepts 2 times -6. This tells me a must equal 3 over -12, so the a value is -1/4. So my final factored form would be -1/4 x minus 2 times x plus 6. Here's the next one. I want to know the x-intercepts. Do I know where they are? No. It could be there are no x-intercepts, which means factored form would not be any good anyways. But what I do see is these 2 points have the same y value. That means they must be equally spaced, just like with the x-intercepts that had the same y value. They had to be equally spaced. So I could find the axis of symmetry by counting over again. 1, 2, here's the axis of symmetry. And so what I do know is that point is the vertex. So I might want to use vertex form. F of x equals, I don't know a, x minus h. Well, the h is the x value. So if I'm at -6, that needs to be a +6. Opposite signed from where we're at. And then plus k is +1. Now, I could use that formula again, but to use the formula to find a, I would need to know the y-intercept. Do I know the y-intercept? Do you know where it crosses the y-axis? I don't. There may be some ways I could figure it out by counting, looking at old critical points, but that way's garbage. Right? That's only for me and my twisted brain. So what we can do is, we don't know a, so my only other 2 unknowns are x and y. Well, do you know an x and a y that are on this graph? Here's a point that has an x and a y that's on that graph. So plug that point in. So the y value is 4 equals, I don't know a, the x value is -3 plus 6 squared plus 4. This is going to give me 4 equals a times 3 squared plus 4, which is 9a plus 4.
Where did you get 4 at the end? It's plus 1. It's plus 1.
Yep, 1. That's what I've been saying this whole time. You people need to listen. Equals 4. Now subtract 1. So I have 3 equals 9a. Divide by 9. So a equals 1/3. So now that I know a, I can plug it back into the original vertex form of a quadratic. F of x equals 1/3 x plus 6 squared plus 4/1. 1/4. The one thing online that it told you, I'm pretty sure that you don't know for sure here, you could probably guess it, that y-intercept is at 4.5. Or if you moused over it, it would tell you. I guess it's still all working. I just need to be patient. So which form did you go with to start with? I know which one I would have started with. Factored form, because I know both x-intercepts. So the factored form would need to look like a times x minus 9 times x plus 3. And again, if you have your parentheses flipped, that's fine. If you have x plus 3, then x minus 9, it's the same thing. Now, I don't know a, but I can find a by using that formula. The y-intercept over, multiply your two x-intercepts. 9 times -3. That means a is 4.5 over -27. So a is -1/6. And so once I go and plug that in, my final answer is f of x equals -1/6 x minus 9 times x plus 3. So what I want you to do tonight, because I need to teach the next lesson today, I want you guys to try the check your progress that goes with that. What page is it? Page polynomial 23 at the top. Can we do that? Try that. Try those tonight and see what you think. I'm skipping ahead. Some of that stuff that I'm skipping is completing the square, which I might go back to, but I don't think it's necessarily required. And I'm going to skip the applications for how much should Dave charge for donuts and the lemonade stand. I really think you have a good idea of that anyways. And we're kind of a couple days behind already. So I looked at what I thought would be good to skip. I think both those are good to skip. Now, tomorrow, we're going to do a quiz on everything we've done to now. Okay, so what I'm going to teach today is not on the quiz tomorrow. We follow that? It's supposed to be a quiz today, but I'm not going to be here 6th period, so I'm going to do the quiz tomorrow when I'm here. And I'm going to teach a lesson, the Can We Predict Stock Values lesson, which is polynomial 33. Okay. I went 2.2. So when I look at the top, it says, functions help us understand how one quantity changes with respect to another. This is especially important when our money is involved. Today we're going to study the value of a stock in a large sportswear corporation over a 1-month period. So the table shows the data for the value of a stock on the teeth, on day T of February, right, where T is the X. So A, is there a linear relationship between the day and the value of the stock? So what is required to have a linear relationship? Well, over equal intervals of the X value, which in this case is T, right, so over equal changes in the domain, we need equal changes in the range. Do we have equal changes in the domain? We do. So let's check the changes in the range. So to go from 230 to 250.70, what? $20.70. So for it to be linear, what must the next one be? Up $20.70. Okay, well, how did I get from 250.70 to 219.20? Well, I would have went down $30.50, $31.50. And now, so is it linear? No. How do you know? Right. Rate of change, not constant. Over, so this is, you got, they're going to be real picky. Over equal intervals of the domain. Another way to say that is the first difference is not constant, right? Same idea. So is there a quadratic relationship? Well, how do we find out if it's quadratic? It needs to have a constant second difference. Well, I don't have enough information yet to find what the second difference is. I need another first difference. So how do I go from 219.20 to 157.10? So I could just subtract $62.10, and it's negative. So now let's see what our differences are. So how do I get from 20.70 to negative 31.5? So I would do negative 31.5 minus 20.70. I get negative 50. Everybody good with that? I know my paper's jumbled, but do you maybe have something better on yours? Everybody good with negative 52.2? Now what about, how did I get from negative 31.5 to negative 62.10? I'll do negative 62.10 minus 31.5, and I get negative 30.6. What you guys got? No? Yes? So, is this quadratic? No. How do you know? Right. Over equal intervals in the domain, the second difference is not constant. So kind of an interesting thing here that I'm not going to take time to go over, but we could, if you were to keep working this out and going to the third difference is constant. So it's a cubic. Okay, so if you want to take time, look at that eventually. It's up to you. But this is a cubic function because the third difference is constant. So they've graphed this for us. Bless you. It says, estimate the first time the value of the stock starts to decrease. So which value gives me, or which variable gives me the value of the stock? So what's our x's represent? The number of days. What's our y's represent? That's s of t, and it tells us, does it tell us what s of t represents? Value, right, if you look at the table. So this is the stock value. So when I ask, when is the first time the stock value starts to decrease? I'm asking, when's the first time the y's go down? That's when the stock value decreases. So when I first go left to right, what are the y's doing? They're increasing. They're going up. When does it start to go down? So it looks like the peak is somewhere between 2 and 3, right? So just past the peak, it has to start going down. So sometime after 2 days, but before 3 days. Right? At some value between 2 and 3, it starts to tilt down. So the first time the value of the stock decreases between days 2 and 3. B, does the value of the stock ever reach at $0? It gets close, doesn't it? I think I see space. Right, there's a little. So does it ever reach a value of 0? No. Explain. How do you know? There's no x-intercept. If you said yes, you would say at the x-intercept. Right? So over this 28-day period, what is the value of the stock at its highest? Okay, so you get that from the table. The table only went to day when? And we're looking through 28 days. So if you look at the graph, right here's day 27. It's here. Does it ever go higher than this point? It does. It continues to go up all the way to the very end. So on day 28, it looks like it's at 450. So the question is, on which day is the value the highest? That's on day 28. Right, it's asking for the x value. And then it says, what is the value of the stock on that day? The second part. So I could say it's approximately, so you put a squiggly line, right? $450. So some things we want to talk about here. Remember between days 2 and 3, we said that the graph started to decrease for the first time. So this is a hilltop, right? It's a maximum value. But is it the maximum value of the 28 days? No, the maximum value happens over here. So we need a way to talk about this being a maximum, because it's changing from increasing to decreasing, but it's not the absolute maximum. We understand the difference between absolute maximum and this kind of maximum is called a relative maximum. That relative to the points it's around, it's the highest. So this one would be called a relative maximum. This point where we almost got to 0, but we didn't quite, we would call that it's a relative minimum, but this is a special relative minimum. Because not only is it a relative minimum, it is the absolute minimum. The graph never gets lower than that at any other place. So this is a relative min, but it's also the absolute min. And then we said the highest the graph got was over here, so this would be an absolute max. Are there any other interesting points that you guys notice on the graph that we've talked about previously? If I go from a relative max to a relative min, yes, there's an inflection point between there because the graph had to switch from concave down to concave up. And the point at which it switched appears to be somewhere right in here, about day between 8 and 9. That's what it looks like for me. So right in that area, between 8 and 9, I'm going to have an inflection, or point of inflection, or an inflection point. Any questions on part 2, A through C? Three is the rate of change of S increasing or decreasing over the interval from 3 to 9. So let me get the picture of the graph back up there so we can look at it. So what is this interval talking about? The interval from 3 to 9? This is talking about the x values. So if I'm looking at x values from 3 to 9, what's happening to the y values? They're decreasing. So the rate of change of S would be decreasing. Let me zoom in. And now that I'm reading that again, I read it wrong. So we still are correct, but it's talking about how are the rates of change changing. So we're talking about the rate of change of the rate of change. So if I think about at 3, if I were to draw a tangent line, it would be something like this. And then at like 6, the tangent line would be more here. And then more here. So because the graph is concave down, the rates of change are decreasing. They're getting more negative because it's concave down. We follow? Sorry, I misread the question. So the rates of change are decreasing, and we know that because the graph is concave down. Questions on 3. 4. Use the table to calculate the average rate of change of S on the interval from 3 to 6 and on the interval from 6 to 9. And were you correct? So how do we find an average rate of change? When you think rate of change, you should be thinking slope. So if I'm finding the average rate of change over, and they give me the start point and the end point, from 3 to 6, I'm finding the rate of change, the slope, between 3 and 6. So this would be y2 minus y1 over x2 minus x1. So from days 3 to 6, we're losing on average $10.50 a day. Now, since it's concave down and we said the rates of changes are decreasing, right? They're getting more negative. What do we think should happen between 6 and 9? That rate of change should be more negative. Because on the entire interval from 3 to 9, we said that the rates of change kept decreasing, kept getting more negative. So from 6 to 9, it should be a bigger change than it was from 3 to 6. So let's just plug in to confirm. So now we're between 6 and 9. So that would be y2 minus y1 over x2 minus x1. What'd you guys find there? Negative $20.70. So again, if you think about, so all these tangent lines I've been drawing, these are instant rates of change, right? At one point that goes through the graph one time, what's the slope look like? The difference is on an average rate of change, we're going to go through the graph at 2 points. So let's think about it. If I go from x values of 3 to 6, one, two, here's the y value at 3. Here's the y value at 6. And so the average rate of change would be a secant line between those 2 points. Secant versus tangent. Touches the graph twice. Now between 6 and 9, here's the graph at 6. Here's the graph at 9. it has a more negative slope because the rate of change is decreasing over each interval. If you looked at instead of from 6 to 9, if you went from 7 to 9, well, you're cutting off this part, so it would be even a little bit more negative. And 8 to 9 would be even a little bit more negative because the rates of change continue to decrease until that point of inflection. Okay? And number 5, for the first 20 days of February, use the graph to estimate the day on which the stock changes the fastest.
Would you say the point like right before the inflection? Would that be?
The rate of change is normally it is fastest at points of inflection. That's where the rate of change is changing the fastest. Now, over here, it's really taking off. Right? So the actual day that has the highest rate of change is probably up here at day 27, 28. But because we're only looking at the first 20 days, it's pretty well behaved. The only big thing is it changes from concave down to concave up. And whatever point it is it changes, that's the day that the stock changes the fastest. So we said that was roughly at day 9. On here they say around day 10. So it's just all about where you pick that point of inflection to be. But it's all just an estimate right now because you guys don't have any way to find it exactly where it's at. So for us, let's just say it's around day 9. It's always, sorry, that looks really bad. I'll rewrite day. It happens at the point of inflection. So here I'm going to put up the quick notes from today's lesson. And then I'm going to also put up the quick notes from the lesson we did yesterday because I know we still haven't got to look at those. You guys can copy them now if you want to wait and copy them on the video, however you want to do it. If you'd rather spend right now working on the check your understandings. But we've got, so here's what we're looking at. We've got 2 check your understandings that I want you to do tonight. Okay? And then you've got a quiz tomorrow. If you're wanting to do Canvas stuff, and again, no deadlines on any of that stuff yet. I think everybody's joined the class finally, so we'll start getting a better schedule. 2.1 and 2.2 you should be able to do. I think now you should be able to do 1.5 if you want to start looking at 1.5. But again, no due date on that. Don't think I've got to do that tonight too. But hey, if you got a lot of free time, you want to kill some time, that's an option. So let me tell you the main questions here that are on the quiz that you're going to be taking tomorrow. 1, it's going to ask you to find the y-intercept. Now the equation is going to be in factored form. So how can you find the y-intercept when it's in factored form? What's a good form that shows you the y-intercept? Standard form. So how can I go from factored form to standard form? Distribute. So what I would do there, if it's in factored form, distribute it, and you can get it into standard form, and you can identify the y-intercept. Right? Just switching between forms. 2 is the one that's about writing it in vertex form. As I'm looking at it, it's not going to be on there. So I may change that question and ask you to put it into factored form. It's currently in standard form. So we're going to, question 1, you're going from factored to standard. Question 2, from standard to factored. Easy enough? That's just factoring. You just factor. 3 is you're going to be looking at a graph of a parabola. And you're going to ask, how do you maximize profit? You're going to be asked about how much money should you spend? And will they or will they not make a profit? That goes back to some of our earliest lessons that we looked at. All right, I think that one's pretty easy. 4 is a transformation of a parent function. Transformation of a parent function. So make sure you know what all your parent functions look like and how the transformations move them. Okay, it's a multiple choice. Look, it's not going to be, I'm giving you 4 points on a quadratic like we did yesterday. It's not that. It's the very generic transformations. Left, right, up, down, stretch, compressed. 5 is all about rates of change and the difference formula. Your f of x plus h minus f of x all over h. It's some of that stuff, and it's some rate of change stuff. 6 is graphing a piecewise function. Stuff that stuff we've done on Canvas that I know you practiced a bunch, along with stuff we went over in class. I think it all ties together pretty well.